So this question, they ask us to find a value of a that will make f of x continuous. So if this was a short response, we would have to show all of our work. So how would we show our work? Well, first we have to show that the limit from the left side and the limit from the right side are equal, because if they're equal, then that means that the function is continuous, right? And also we have to show that and after that we have to show that even though the right hand side and the left hand side limit are equal, we have to show that it's not an open circle. And so the question is, what value do we choose? And we're going to actually choose the value of -2, because -2 is the value of difference, right? If you're a little bit less than -2, then you get a different output. If you're a little bit more than -2, then you get a different output. So since -2 is the difference, we're going to test this at -2. We're going to test the right limit from -2, we're going to test the left limit from -2, and we're going to test the value of the function at -2. And if they're all equal, then we can say that the function is continuous. So let's quickly show our work for that. So right now I'm going to test the limit from the right. So for example, we have a plus sign and we have -2. So we're going to be coming from the right, meaning we're coming from a value that's a little bit bigger than -2, like not 1.999, -1.999. So we're going to put that basically into the value which of the piecewise functions are we going to use? Because we're going to use the one that's greater than -2. So this one is greater than -2, right? So we're going to write it out. So it's going to be x cubed plus 4x minus 1. And when we plug in -2 to each one, this is what we get. We'll get that it's -8, and then we'll plug that in. It'll also be -8 and minus 1. So it becomes -17. So coming from the right, the limit will be -17. What about from the left? So let's see, limit as x approaches -2 from the left of ax squared plus 3, and then we're gonna see, so we're coming on the number line from -2. We're coming from values that are a little bit less, like 2.-0.0001, right? Like this value right here is a little bit less than -2. So we're gonna plug that value in basically for here. So when we do that, we'll get that it's equal to 4a plus 3. And remember, we want to see what value of a will make them continuous. And a function is continuous if the left limit and the right limit are equal. So this guy has to be equal to this guy. So we're just going to set up a pretty quick equation. We just let this equal negative. Okay, so if we were showing our work, we want to be more organized, like on the AP test. So we will be like 4a plus 3 equals -17, and a equals -5. So since this is the case, now we have to show, we're going to plug 5 back in. After you've shown this work, you want to plug -5 back in. So we got that, we would keep that work on the AP test. But we would say a is -5, then we have the limit coming from x going to -2 from the left, and limit as x is going to -2 from the right. So we're gonna just evaluate. So if you're coming in from the left, you're a little bit less. So if you're a little bit less, you're a little bit less. So you're gonna use this one. But now we know that a is -5. So we're gonna say x squared plus 3. And this one just stays the same, right? And so when we plug in -2, what do we get? Here we will get -17, here we will get -17. Now we're just going to make sure, okay, the limit at -2 is the same. So the right hand side limit is the same, the left hand side limit is the same. We've already shown that. But if we just write that, we're not going to get full credit, because the definition of a continuous function is that the right and left hand side limit, they're the same, but also is the limits are the same, but the value of the function at that limit is also going to be the same. So basically what I'm saying is that we just have to show what the value of f of negative 2 is equal to. And if that is equal to negative 17 as well, then we're all good. So when we plug in negative 2 falls under this category, so we're just going to basically write that one out, negative 5x squared. No, well, we plug in a negative 2 instead of x, and then square that plus 3, and look at that. It's also negative 17. That makes sense because it's the same one as this. So when we do that, now we can say at a equals negative 5, all of these are true, that making f of x continuous. So that's how we do this kind of problem.